2, 1.
Hey guys, we have another question today, which is 1 factorial times 2 factorial times 3 factorial times all the way up to 400 factorial divided by 200 factorial. We have to prove that this is a perfect square.
So how would we do that? Well, it seems tempting to cancel out the 200 factorials immediately.
It does.
But it doesn't seem like there's going to be something after that. So let's find a different way to cancel out the 200 factorial.
We'll do that first by rewriting the numerator terms.
Yes. So let's put all of the even numbers,
Odd numbers.
odd numbers,
Yeah.
together. 3
Yeah.
factorial.
See here, we're just separating the even from the odd. We're rewriting the same thing. It's equivalent. However, we're just separating the even from the odd.
And then we have our even. Right, big
Yep.
giant brackets. All the way to 400 factorial.
And then we're going to further develop this even part of the numerator into something else.
The odd part as well. Yeah. So let's look at the odd part first. So can we do anything out of the odd part? Not really, right? It didn't seem like we can do a bit of factoring or anything. But the even one, we can factor 2, right?
Yeah, we can always factor 2.
So let's do that. So first, the 2 factorial can be written as 2 times 1 times 1 factorial. Notice how we shaved the final number of the factorial.
You may find that this extra 1 looks redundant, right? But I assure you that further on, there will be use for this term.
So the next one, 4 factorial, is 2 times 2 times 3 factorial. And then 6 factorial becomes
2 times 3 times 4 factorial. 5 factorial.
Yeah.
Yes, sir.
All the way to 400 factorial, which
Just
is
2 times 200 times 399.
Factorial. Nice. And now
What can
see
you observe?
really cool things, such as
You can see that there is a repeating 2 in every one of these terms.
you also can see that there's a 1, 2, 3, all the way to 200 in these terms. Now what does that become? That becomes a new 200 factorial.
Yes, sir.
And
finally, for the third term, you can see that these correspond to the odd part of the numerator.
yes. So how many 2's are multiplied together? Well, it turns out that 200 of them are multiplied together.
Yes.
So we can write 2 to the 200
Yep.
times,
The second terms together,
which
it
is
is also
200
happens to be 200.
factorial.
Yep.
And then multiplied with all of
1.
these together.
But don't forget what we have here as well. So we can
actually square
Square.
them. Oh, so we have a lot of squares now. All the way to 399 factorial.
squared
all over
200 factorial.
So now we can cancel out the 200 factorials. And we're left with a square. It's 2 to the 100
Yep.
square
This can be written as a perfect square.
multiplied by that
Another
square.
square.
And
Which in turn proves that this entire term can be a perfect square.
perfect.